This is a past leaving cert question, Chemistry Higher Level 2009, question 10a. And this is on gas laws and the mole. So the first question is asking us to state Avogadro's law. Then we're asked to give two assumptions of the kinetic theory of gases. And then we're to give two reasons why real gases deviate from ideal gas behaviour. And finally, we're going to be asked a maths question to calculate the number of moles of gas present in a sample containing 1.8 by 10 to the 24 atoms of chlorine at standard temperature and pressure. So that first question was asking us to state Avogadro's law. And Avogadro's law states that equal volumes of gases contain equal numbers of molecules under the same conditions of temperature and pressure. Then two assumptions of the kinetic theory of gases. Well, the first assumption would be that there are no attractive or repulsive forces between molecules. And the second assumption would be that gas molecules are so small that their volume is negligible or zero. The next question that we're asked is we're to give two reasons why real gases deviate from ideal gas behaviour. And this is essentially that those assumptions are not true. So we know that there are attractive and repulsive forces between molecules, and the volume of gas molecules is not negligible. So the next question is asking us how many moles of gas are present in a sample containing 1.8 by 10 to the 24 atoms of chlorine at standard temperature and pressure. We'll pick out our key information. So we're told that we've got 1.8 by 10 to the 24 atoms of Cl, of chlorine. Now to answer this question, we're looking for how many moles of gas are present, not how many moles of atoms are present. So we must recognize to answer this question that chlorine gas exists as Cl2, as a molecule of two chlorine atoms joined together. So essentially, one molecule of gas is equal to two atoms of chlorine. So we've got a ratio of 1 is to 2. Okay, so we're told that we have got 1.8 by 10 to the 24 atoms of chlorine. So looking at a ratio, 2 atoms is to 1 molecule. So we have to divide our number of atoms here by 2. So we're going to divide this by 2 atoms per molecule. And that's going to equal 9 by 10 to the 23 molecules. So it makes sense that we've got less molecules than atoms. Now we need to convert from molecules to moles. And to do that, we must use Avogadro's number. And this can be found on page 46 of your Formula and Tables booklet. And Avogadro's number is 6, and we can ignore the decimal places thereafter, but 6.02 by 10 to the 23 molecules or atoms or particles or things per mole. In this case we're going to be using molecules. So we know that 6 by 10 to the 23 molecules is equal to 1 mole. Now we've got 9 by 10 to the 23 molecules. So what we're going to find out here is how many moles here would be just one molecule, and then multiply it by the number of molecules that we have. So we're going to divide both sides by 6 by 10 to the 23. And that is going to equal 1 molecule is equal to 1.667 by 10 to the 24 moles. So we divided both sides by 6 by 10 to the 23. And now we want to multiply by the number of molecules that we have. So 1 multiplied by 9 by 10 to the 23 is going to equal 9 by 10 to the 23 molecules is going to equal, and now we need to multiply 1.667 by our number of molecules, and that's going to equal 1.5 moles. And that is our answer.